Welcome back, YouTube and Instructables. Today we're going to talk about how to build an integrating sphere. If you saw my last video, internet lumens versus actual lumens, that's the device that I use to take those measurements. And we're going to build that, and we're also going to build a lesser known device called a lumen tube. So what you're going to need for materials is, first, you'll need a light meter. This is mine. It's the LX1330B, and I chose this particular meter because, for one, it's cheap, and for two, it has a very, very high measuring range. It can go up to 200,000, and so that means that you can measure bigger, brighter lights. The next thing that we're going to need for our integrating sphere is something to contain the light. What we do is trap all of the light coming out of the end of our device, in this case a flashlight or an LED emitter, in one place so that we can diffuse it and measure it, and so you'll need a sphere. Yeah, okay, I realize that the word sphere implies a round ball, and you can get round balls that are hollow, but those are expensive, and let's face it, expensive is unpopular. You could even go to the free store and get one of these. Now that we've got our materials together, let's begin. The first thing we'll need to do to make our integrating sphere is cut a hole so that we have a port to put the flashlight in. All you got to do is just trace a little circle on here. And you can, if you have a hole saw, that'll work to cut it out with, but you don't need one. You can just use a razor knife and just cut this circle out of the middle. Now that we have that done, you can see right here alongside it, I've also drilled two smaller holes, and these are going to be to hold the sensor for our light meter. What we want to do now is make something so that we can fasten our sensor, this is the actual light sensor, to the back wall, and I just used a metal plate with a couple of bolts basically. A zip tie or anything would work, but we want to stick our sensor down in there like that and then fasten it so that it's in a fixed position, always the same position, so we get more repeatable results. Basically what we're trying to achieve is we're going to fire our light in here and bounce it off this back wall, off the white, and all through here, and then when we measure it, it's not, the flashlight isn't firing directly into that sensor. We get we even out the light as best we can and then measure it. The basic science of measuring light this way is to do three things. First, we need to gather all of our light in one place. The next thing we need to do is to integrate it, to make it be as even and smooth of a beam as possible, kind of mixed all up like something in a shaker, and then we need to measure it. Because we're using a cube rather than a sphere for this, ours is going to be just a little bit less accurate than if we had spent the $30 or $40 extra to get a round ball, but we can still get fairly accurate and repeatable measurements if we do one thing correctly, and that's the trickiest part, but it's to calibrate. In order to properly calibrate, what we need now is a known source. And I happen to have friends in the industry, so for my first light, I just had one of them use a proven system. I sent them a flashlight, had them test it, and then had them send it back to me, and I was able to calibrate off that. And now you don't have to have that, though. You may not have a bunch of friends that do this or anything, so there are other ways, and you can get like a quality flashlight. Foursevens brand, I think, is a good one. Their numbers are pretty consistent. Now, the ratings are not going to be exact. If you buy a 640 lumen light from them, you might get one that's 660 or, maybe a little less or whatever. But it's going to give you a good starting point. And something else you can do is get, several different ones and test 3 or 4 or 5 and then average the numbers together. And what you'll what you come up with is what we call a multiplier, and I'm going to show you how to get that. In order to achieve our multiplier to calibrate our system, what we need to do now is turn the light meter on, and this particular one comes on in lux, and that's not what we want. Foot candles is the total volume of light, and lux is distance, and what we want is to switch that to foot candles, and we're getting a reading just off the residual light in here. This is set very low, so what we do is bump it up, and you see the decimal point moves, and then when we hit it again, we go to the maximum setting, which is times 10 for that number, and then we're going to put our first known source in here and see what number we come up with. When I fire this light in here, we get it, and it bounces around just a little bit, and what I always do is, some people put a piece of glass there, but what I do to get a little bit more, what I think is an accurate measurement, is I move the light in and out just a little bit until I find the highest point. Right there we've got 180, and what I typically do for this, because when you very first turn a flashlight on, it's going to give you a much higher reading on this. I wait a set amount of time. Hit your stopwatch. I go 60 seconds. It doesn't matter really what you do, as long as you do that same number each time, and that'll allow the output to settle to what it realistically is for that. You'll get a lot more true measurement if you go out to 1 minute, as opposed to if you go at like 5 seconds. You'll get an unrealistically high if you just do it 5 seconds or something. So I would say at least do 30 seconds. Now, the way that we use the information we just gathered is like this. I know that this light happens to be 640 lumens, and on our light meter we got a reading of 1800 foot candles. So we take 640 divided by 1800 equals, okay, and we get 0.35. Now, from now on, when we stick an unknown source, a new flashlight, inside of our integrating sphere, we take the number that we get off of our light meter and multiply that number by 0.35. So now that we're calibrated, we're going to try an unknown light, and we're going to fire it into here. We calibrated off of this one, and we're going to shoot another light in here, and I'm going to show you how you get your measurements now. We turn this on, and our reading here is 8.6, and we add a 0 because we're on 10 power right here. And what we do with that number, we take 860, and remember we multiply it by 0.35, 301 lumens. Okay. I said this was an unknown source, but this light here is rated, this particular model is rated at 280 lumens, and we got 300. Now, had I waited a full minute to take the measurement like I should have, 280 is probably exactly what I would have got. So really, our calibration is pretty good. One other thing I want to mention is when I did the individual bare LED tests, you will need to calibrate differently for that, just because this is not the best integration you're ever going to get. This is not a professional device. So when we're shooting a flashlight in there, all of our light is bouncing off the back wall and a little off the sides and then coming back to the center, or to the sensor, and that actually works pretty well if all you're going to measure is flashlights. But because all of this light is already spread out, you'll have a different calibration number, so you would need to have a known source for this and come up with a new multiplier, which is what I did when I tested this and the 100-watt emitter in internet lumens versus actual lumens. Now that we know the science of measuring lights, it's time to move on to our next device. And I didn't invent this, and its origins were, a little sketchy to trace. I'm not going to name anybody because I would probably get it wrong, but I am going to post the links in the description if you'd like to see where I learned how to do this. Building this device only required a trip to the hardware store. As you can see, all I've got is some pieces of PVC pipe, and I've got some pretty large diameter stuff, 4-inch, but you can use smaller pipe for this. I chose larger pipe because the bigger the pipe, the bigger the light I can get in there, and I make a lot of oversized head lights, so this was what was best for me. But all you need is basically a couple of elbows, the connecting pieces. I think this whole thing, including this flange and this cap, cost me $19 and change, so it's not real expensive. And basically the idea is just to integrate the light a little better before it hits our sensor. And what here's basically what happens. You fire the light in this end, and you can see it comes out the other end, but it's much softer. It's been integrated and diffused. And so what we'll do for this one is, for this cap, we'll make a hole that we can fix our sensor into and then shoot our lights in. For the lens on my Lumen tube, I decided to use a piece of this True View museum glass. It's really super clear, and you can see I'm getting a little reflection in that from the chandelier above me, but basically it's got an anti-reflective coating on one side and a UV coating on the other, and it's the closest thing I've ever been able to find to true double AR coated glass. So now we're ready to go with our Lumen tube. We've got our piece of glass set up in here and the light sensor attached. I cut the hole in there and made a snug fit for that and attached it with the handyman's secret weapon. I have seen people do it with the square caps where they didn't even need that, but this was easier, so that's what we went with. And I also made this little foam shroud that will sit around the flashlight to block the extra light here. This doesn't really, I haven't noticed that it actually changes the reading on our meter, but it does keep us from getting the backsplash in our eyes. This time, rather than setting to the highest setting, I went down one because we weren't maxing out this, so we won't add a 0 to that number this time. We're not on the 10 power setting. Okay, so off we go with our calibration. And let it level off just a little bit there. We're just going to go ahead and use 193 for this. We're not going to wait the full amount of time. So we take, to get our calibration, we go 640 again, divided by 193. Now our multiplier is 3.31. It was 0.35 for the other device, and this one it's 3.31. Okay, so now we're going to test our other light and see if our calibration's good. Got 97, so we go times 97, and we're getting 320 lumens this time. 320 lumens, 21 lumens, which is still pretty close. That's a little bit high. We're 20 lumens high this time. We were But that's still, that's a reasonable margin of error for something like this, I think. Another thing I want to mention is I would think that a device like this would favor throwers quite a bit, but it's actually not that bad. You would think that anything that projected the light down in there really, really well would get a much higher number, and I haven't found it to be too much different, and the reason I know is because I'm using a mag light, which is focusable. I can focus into a tight hot spot. You can't see it there, but I can focus this into a tight hot spot, and well, let's just do it. Let's put it on there. I've got it set on as tight as it'll go, and we get 268, and going to a very wide hot spot, .258. So that's not perfect. We're not really losing any light because we're still getting basically all of the light. The change of focus, just moving the head this tiny little bit, we're not actually really losing any light, and the height of the emitter is not changing that much. So this does favor a thrower a tiny bit, but not nearly as much as what I would have thought. On the other hand, if you're measuring one of these, this is what they call a zoomy flashlight, where the head, it's got that spherical lens, and the head, the way the focus works on this is you move this in and out. This light in either device is going to measure very, very different on the wide versus the throw, but it's actually the opposite. When you're on wide focus with this, because the proximity of the emitter is so much closer to the sensor, and also when you move this head up, you're actually blocking light from being able to escape out the sides. So even though your focus is tighter, your beam's headed down the tunnel better, you're losing a lot of light. So you'll get quite a bit different reading in either one of the devices. So we'll put this on, and there's our wide focus, and then when I zoom out, we're down to like 50%, but that's not really this. That's actually, I think, kind of accurate because you're blocking the light inside this. One other element to consider when doing this kind of testing is temperature. This can have a pretty significant impact on the way your test turns out, especially when you're dealing with batteries and flashlights that use a linear regulator. An ambient temperature of around 70 degrees is good, but as long as you're in a controlled environment, you're going to get better results. If you were to take and put all of your equipment and your battery and your light and everything outside in 40-degree weather, it's going to perform at a much lower output, especially because the lithium-ion batteries don't perform nearly as well when they're cold like that. And also, you can also get a falsely high reading if your battery is too warm. If it comes right off of a charger, when you charge them, the internal temperature comes up. You can even feel them, and they're kind of hot. So you'll want to take your battery off the charger a couple hours before you're ready to use it to get a consistent result. If you've enjoyed this video, you can click subscribe and you'll get a notification when my next one is ready. Also, if there's a video related to flashlights or light measuring, something you'd like to see a tutorial on, post it in the comments and I'll make a video about it if I can for you. Good luck.